Hello, and welcome to our project video. This video documents our journey in building a simple AC generator, highlighting the continuous improvements we made across three major design iterations, from recycled stator-based structure in version 1 to horizontally driven solenoid-like coil in version 2, and finally, a fully functional three-phase system in version 3. Each step brought new challenges and new solutions. Through hands-on trials, problem-solving, and teamwork, we gradually transformed a basic concept into a more refined, effective, and stable generator design. Let's begin by taking a closer look at how our very first version was made. In version 1, we constructed a basic AC generator by repurposing a motorcycle alternator stator as a fixed coil component. A circular cardboard disc was attached to the top of the vertically mounted wooden chopstick, which served as the rotating shaft. Several permanent magnets were glued around the edge of the disc in alternator N as polarity. As the chopstick was manually rotated, the magnets passed over the stator coils, generating alternator voltage through the electromagnetic induction.
However, when we operated the initial version of the device, we found that the induced voltage was relatively low. Upon reflection, we realized this might be due to the arrangement of the magnets, placed on the outside of the stator and spaced relatively far apart, resulting in weak magnetic field strength between them. To address this, we optimized the device into version 2. In this version, the coil is wrapped around the outside of the stator, while the magnets are placed inside the stator, rotating to cut through the magnetic field lines. So, we removed the copper wire from version 1, crafted a new stator using cardboard, and rewound the copper wire onto it. At the same time, we used hot glue to fix the magnets onto a chopstick, and this is the demonstration video of working principle before wrapping the copper wire around the stator. Well, actually, from the video, it's clear that when the rotation speed is too high, the magnets, which were only held together by the mutual magnetic attraction, risk flying off. So in the final stage, we redesigned the rotor. We made a small cardboard disc and secondly fixed the magnets onto it in alternating NS order. This gave us a more stable device like this. Unfortunately, we were so focused on the experiment that we forgot to record the video in this part. However, we did manage to document in final waveform we obtained.
Okay, so now come back to the sine wave that we saw. This plot of current also represents power. And if we connect the lab into the circuit, we will see that it will increase the brightness all the way to the peak, that maximum point. Then it decreases in brightness all the way down until the neutral point where the lab is actually off because no current is flowing. But then it will decrease in brightness again as the negative half of the cycle comes through, and the electrons start to flow back through in the opposite direction until again it reaches the neutral point. So at this point in the cycle, the lamp is not producing any light, and at this point in the cycle, the lamp is not very bright, so it's not of much use. To solve this problem, we upgraded to a three-phase circuit in our V3 design. Let's take a look at how it works. In a three-phase system, we have three coils arranged at 120 degrees phase differences. When the rotor spins, these coils generate three alternating currents that are out of phase with each other. And if we consider the total power in the three-phase system, something amazing happens. The total power remains constant over time. This is a huge improvement over the single-phase system. In the single-phase case, the power fluctuates between 0 and twice the average power. But in the three-phase system, the power is always 1.5 times the average power of a single phase. That means the lamp connected to a three-phase circuit will shine with the static brightness without any flickering. Then we started the production of device V3. First, the cardboard in V2 was cut into 3 uniform parts as winding formers, and then the copper wire was also cut into 3 equal length parts. Finally, the same number of turns were wound counterclockwise on the winding formers. Then, the 3 sets of coils were arranged on the newly cut disc at a phase difference of 120 degrees. And the production process of the rotor is just like this. Finally, the device was assembled to obtain our device V3. Let's try to run the device and get a stable sine wave. The experiment was a complete success.
In this assignment, I was mainly responsible for the hands-on parts of the experimental setups and analyzing the problems that occurs in the devices.
In the assignment, I was mainly responsible for sourcing the material and designing the structure of both version 1 and version 2 of the experimental setup. Additionally, I work alongside the other 2 group members to assist one body in conducting the experimental procedure.
In this project, I was mainly responsible for the design of the experimental device V3, the post-editing of the video, and the content drawing and the organization of the experimental report.
Hello, I am Zhu Haiyang. In this assignment, I was mainly responsible for the integration analysis and the documentation of the data.